Good afternoon, all. Myself, Professor Sudipta Chattopadhyay from India, Mizoram Central University. So, in our research laboratory, we have found several insightful exploration for the first time. So, out of them, whichever I have got in front of me, so I have portrayed here. So, the title of this short presentation, where I have given some exemplary new novel work which is coming out from our research laboratory, so that is portrayed. So few sample explorations in the frontier of printed microstrip antenna, few novel observations and first ever developments which we have done, so that thing has been portrayed in this talk. So, pioneering insight into the cross-polar radiation minimization, first ever findings, which we have, this is the title of this slide. And here, actually the cross-polar radiation is the unwanted radiation, which is not at all serving our purpose. Instead, copolar radiation are very important. So, for polarization purity purpose, so it is very important technique to develop. Different techniques have already been different technique means before this one defected ground structure thing has been evolved. So although it was not our claim, this was done for circular patch, but our claim can be which I will tell in the later section, that is the employment of that technique in rectangular geometry. Anyway, before going to that, first of all, the first concept which we have developed, that is DPS, which is DPS abbreviation stands for defected patch surface. So defected patch surface, it is elaborately explained in 2016 IEEE Antennas and Wireless Propagation Letter. So it has addressed the issue of cross-polarized radiation minimization technique. So how it can be minimized, and that technique we have later time we have already investigated the fact. Even in the some companies also have used the thing, so that is their means it is found that it is satisfactorily working, and it is for rectangular and circular geometry of patch antenna. And rectangular and circular geometry we have preferred because of their established theoretical concept, and the industries generally prefer to use the conventional geometries. So whatever techniques we have evolved here, so that has been examined over the conventional structures. Okay, and here the analysis of the fields inside the patch cavity is very crucial to determine the position of the defect. So where we will put the defect, this is not very means easily we cannot find it. We need to carefully inspect the field configuration beneath the patch, within the patch cavity, so accordingly we can put the defect. And these are the examples of defected patch surface. So in the top left side here, you can understand this is there is a patch, and over the patch there is a cut of dumbbell shaped cut. So this is basically a defected, it is defecting the rectangular patch geometry. So definitely defect will incorporate the current path modification as well as the patch cavity field modulation, and therefore it will behave differently. Differently means definitely the excitation of the resonance will be similar, but its radiation pattern, fringing profile, that will be getting affected. And mainly it will affect the fringing profile in the non-radiating sites. So in this non-radiating sites, this has been adopted, this defected patch surface. Here in the middle picture you can see there is a deformation of the rectangular patch in the form of a T. It's fabricated figure here, and in case of circular geometry the two sides have been cut, and this has been shown here. So this is the fabricated version. Another thing we have seen in this picture, in the rectangular geometry, two arc lines have been cut. How to cut this arc line means what will be the curvature, RA1, RA2, different things have been shown here. This is the fabricated version of this one. So it has been analyzed and everything, you can get it in the elaborately in the journal paper, the full analysis. So if you search it in my name in the major search engine, you will be getting the papers. So these are mostly in IEEE or IET or Cambridge International Journal of Microwave Wireless Technologies, Cambridge University Press. So these are some examples of DPS. And second technique which we have evolved, so that is the shorting of the patch. So shorting of the patch, it may be discrete, it may be continuous. So any type of shorting we can use to effectively minimize the cross-polar radiation. So this cross-polar radiation, it will this effective shorting basically not only reduce the cross-polarization, but also it modifies the mode of the patch also. It is TM11. The full analysis has been given in IEEE Antennas and Propagation Magazine 2014. Careful analysis has been done step by step. You can understand how the modes have been developed. So these are the this is the concept of shorting patch, where we have used the continuous short. Okay, so these technique also have been examined in rectangular and circular geometry, and here the frequency little bit increases because of this your mode conversion from TM10 to TM11 in rectangular patch geometry, and the analysis of field perturbation due to the feed also to be taken into account. Okay, so means it will not be generally in the cavity model we generally analyze the source free cavity, but with source some perturbation comes and which will modulate the field beneath the patch, for that also to be considered. Okay, so this is the basic concept. Here you can see the continuous shots are there in the non-radiating side. This is the side view, and the resultant formulation for resonant frequency of TM11 mode, that will be this one, where the field variation EX and HZ are only there, and these EX and HZ, this will be proportional to this. Okay, so from this you can understand how will be the field profile, what will be the mode if there is a continuous shot. So this shot can be discretized also. So if we are you can consider that in many strips, if we are putting in the non-radiating sides, so it will simulate the continuous shot. There is a concept of use of wavelength. Use of wavelength means use of frequency, because we know as the frequency changes, the wavelength also changes, so that this discrete shot can be seen as continuous. So these things, at the same time some leaking is also there if that thing is not considered, the wavelength issue is not considered. So anyway, but in most of the cases continuous or discrete shot is the effective technique which has been shows the scientific community very long avenues with which the many people has also worked based on this. And here it is, you see in the left hand side there is a discrete shot, 3 shots are there. So here also this is the fabricated version. There we have also got the similar thing, the effective cross polarization minimization has been obtained, and along with in every cases we have found that whenever we are using a discrete shot, there is some advantage in terms of gain as well as some pros and cons are there. For example, you see this one and this one, here it is a comb shaped patch, so it is a combination of defected patch surface as well as the shorting strips are also there. So this is the fabricated version. So you can understand that here we are considering both the things, DPS plus the shorting technique, and here we have found very beautiful effect along with the cross polarization minimization. A huge bandwidth we have got, so bandwidth is also there. So this can be analyzed through the Q factor of the structure. So this thing is reported, you can see it in the one German journal, that is Frequenz. Here you can get it, and this is also there. So these two things are also effective technique for cross polar reduction. And then we are coming to the circular patch. In circular patch also continuous strip has been given here. Here you see, but how much you will extend this, because you know in case of circular microstrip antenna you cannot distinctly say that this is a radiating edge, that is a non-radiating edge. For example, in rectangular patch you can say this is radiating edge, this is non-radiating edge. But in circular patch the field profile is like that, it will be reduced here. So this side, a small section will be a non-radiating side where there will be zero electric field, but here the strips are given more. How much it will be extended, its detailed calculation you can get in IEEE antenna and wireless propagation letter, probably 2022, and if you search it in my name you can get it. The full elaborate analysis is there, how the fringing aperture has been modulated in this way. So this thing has been designed there accordingly. If it is basically for phi 1 plus psi is 125, 55 to 125 degree, if we are making this continuous shot, then it can modulate the aperture, and it results in very high efficiency along with horizontal both side to horizontal gain enhancement. This is a very important issue, because in other cases the horizontal gain basically wasted, because this is a both side radiator. So both side gain will be reduced because of the horizontal side radiation, and horizontal side radiation not only do this problem of reduction of gain, at the same time it will produce a surface wave. It will move on through along the surface of the dielectric, and at the point of truncation it will be diffracted and it will hamper the radiation pattern. So this thing, in the analysis you will see that this thing perfectly suppress the reduced surface wave, means surface wave. It will reduce the surface wave. So surface wave is basically, surface wave reduction means definitely there will be the decrement of horizontal gain enhancement. So if there will be decrement, therefore the both side gain will be enhanced. And this is the DPS with shorting in circular microstrip antenna. Here DPS, you can see the circular patch has been deformed with this thing. This is the fabricated picture, where here we have put some shots. So these shots are basically handling the horizontal radiation by the polarization current. So this is given in IEEE Access 2023 or 2022. With my name you can get all these papers where all the elaborate analysis are there. So here you can we have said that here the cross pole can be minimized, gain can be enhanced, and at the same time efficiency will also be very good, and the bandwidth will also be good. So this is also another technique. So these things are first ever designed from our side, and these concepts are basically following these concepts. Later on many people worked based on this. And what I said at the very beginning, that is defected ground structure, it has been for circular polarization, it was proposed by other scientists, but in rectangular geometry we have done. This is the slot DGS and this is the dumbbell shaped DGS. Here you see how much it will be penetrating beneath the patch, that is A, and A can be formulated like this. You can get it in IET microwave antennas and propagation 2017 or something like that. Okay, so with my name you search, you can get it. And these are very few, some means very in a nutshell I have given some of the works, very few works, and besides those some very good works are there, which is microstrip monopole antenna with its quantitative and qualitative analysis, employment of air and artificial magnetic conductor composite as a substrate for low frequency underground communication. So which can be replacing our micromode sensor node antenna, and which is commercially available. It can excite 413 megahertz or 417 megahertz in measurement, 417 megahertz frequency, and with good gain around 2 dBi. And this is the evaluation of transverse electric mode excited patch. This is also very few works, means 2 works probably is there, this and followed by our work. Some another work has been proposed from other part of the world. So this is a transverse electric mode excited. This is also for underground internet of things application. It is very good because it is having wider bandwidth. This is the full analysis you can get in IEEE transaction antennas and propagation 2023. And employment of reduced surface wave concept in radiation science, that also has been in every paper. It is elaborately physics has been given. Heterogeneous AMC grounded antenna, which is exploiting the quasi-AMC property in radiation in multi-frequency domain, which is also important for wireless underground sensor network. It is there in IEEE Antenna Wireless Propagation Letter 2023. So these are basically the works. More works are there. We have not discussed. There is no much time. So thank you.